Sai Ram. Having seen certain examples, certain basic aspects of this new concept of adsorption, now let us slowly get into what this concept is all about, what are its chemical indices, that let us see. So in this part now, we are going to mainly study about the factors that correspond to this adsorption and various types of adsorption that we come across. So here we have some of the factors that depends the adsorption strength. So it is given there the extent of the molecules, generally gases. So on what extent do these molecules get adsorbed on a solid surface is dependent on all these four factors which have been present. So the first factor is nature and the surface area of adsorbent, which means that the layer that you have, how best and what is the nature of that and how much is the area, because if the area is too small you can't adsorb more. So your extent of adsorption will depend on this factor. Nature of adsorbed gas, because even the molecules which are coming for adsorption, they also need to have similar bonding properties with respect to the layer. Now if they are totally repelling in nature, repelling indicates moving away. If they are totally repelling in nature, then it cannot be worked out. The third one is temperature. I think for this a little bit of basic understanding about the relationship between temperature and molecules have to be revised a little. No doubt you have studied that, but those factors have to be kept in mind. And then finally, pressure of the gas. Now, pressure is more or less related to temperature because generally you tend to correlate both these aspects. So these are the major factors that we come across. Let us study all these factors in detail with respect to what is needed for adsorption. Let's take up the first factor now, that is nature and surface area of adsorbent. Now it so happens that all the compounds are not same. They will never have same properties. So naturally the properties of these compounds will be varying. Now what are those variations we see there is that the same gases, if there are similar conditions also, it will not get adsorbed at the same rate. Suppose if there is the surface variation is found, same gas, same conditions around, the adsorptions may differ because the nature of the layer is very important. Now in this case what we tend to see is that if we have a layer as such, its size will definitely matter, because more the area, if this is the large surface area that you have, more the area, naturally molecules going and settling on them will be more. If the area is less, the adsorption also will be comparatively less. Now what does this factor of nature mean is that the chemical forces or the physical forces which are present between the layer and the molecules should be cohesive. What do you mean by cohesive? It means that both of them should be correlative to each other. Only then the extent of adsorption or the rate of adsorption can be pretty high. Else the adsorption will not happen to a large extent. Now in these, some of the very good examples that we have for adsorption are charcoal and silica gel. Actually we have come across these two examples in a large way. Now they happen to tell that these substances are generally porous in nature. If they have to be good adsorbents, they should be porous. Now the question is, what do you mean by the word porous? Porous indicates hole-like components which are there. So suppose if you have a solid layer which is present, if it's completely solid, then the area for adsorption is some minimum. But if pores are there, pores essentially means small holes. This you actually come across in interstitial compound study in the D and F block elements. If you can just revise that. So what were those interstitial compounds? Gas molecules were going and occupying the small spaces which have been present. Exactly here, what we are trying to tell here is that if it has to be a better adsorbent, then porous nature of that surface is very important, because the more porosity, the more will be the adsorption of the compound. So this extent of adsorption also depends on the surface area of the solid. This is what we have been studying, that more the surface area, naturally more molecules can come and get adsorbed. So greater the surface area, more is the surface area available for adsorption, and greater is the adsorption. So what has been done here is just the theoretical aspects have been put up. The surface area depends upon the particle size of the substance. Now this is important because if the substance particle size is pretty large, then what happens is maybe the attractive forces could be little difficult. Whereas small particles, very easily it can go and settle in those holes, generally the porous thing what we are calling, very easily it can go and settle in that. So this is how various factors determine how best the adsorption can take place. So this was the study of the first factor for the adsorption, that was nature and surface area of the adsorbent. The next one is the nature of adsorbed gas. Now as has been conveyed to you, those gases which are easily liquefiable, what do you mean by liquefiable? Generally which can be converted from gas state to liquid state. Now those which are liquefiable, naturally since they will be converted to liquid state, they will be soluble in water, they can be best adsorbed. Now the reason for this is that on the solid surface, the gas molecules would not like to hold up at a particular position. We have studied that arrangement in solids is strong, liquids is a little bit flexible, whereas gases are quite free in nature. So since the molecules are already far away, it may be a little difficult for you to get adsorbed. Whereas liquids have a particular shape and they have a particular pattern of molecules. So very naturally their adsorption can be stronger. And thus as an example, it has been shown that even under similar condition. Now what do you mean by similar condition is like temperature and pressure being common. So in that similar condition, so larger gases like SO2 and NH3, you can see that the molecular mass is pretty high. So these are adsorbed by charcoal much better than hydrogen or oxygen gas, because hydrogen or oxygen gas, small molecular natures, it will be very difficult for you to liquefy them also, whereas those are pretty much easy. Now that reasoning has also been offered here. It is because the intermolecular forces is stronger in more easily liquefiable gases. Why it is stronger? Because liquids will not have molecules moving all around. So naturally their ability to stabilize on a solid surface will definitely be more. So this is the second factor that we come across in these cases, where let's see now the third factor, that is temperature. So as I have conveyed at the start of this part, that the relationship between temperature and molecules is important for this understanding. We know very well that molecules naturally will be moving all around at their own pace. Now the moment you supply temperature, what do you mean by supplying temperature? It means increasing temperature, or the other way around, I can tell that you are supplying heat. So the moment you supply heat, these molecules which are moving all around will get more energy. If there is an external heat which is supplied, energy of these molecules will be more, so very naturally movement of these molecules also will be very, very fast. So that is what is being told here, that the extent of adsorption decreases with rise in temperature. Reason for this, when you give temperature, you are going to increase the heat. That heat will be absorbed by these molecules, and the moment molecules have more higher energy, they would not like to sit at a particular place. They would like to move around at a much faster pace, and therefore on a surface to absorb them will be a little difficult. So adsorption, now this is an exothermic process. What do you mean by exothermic process? Energy is being released out in these cases. So just as a definition, enthalpy of adsorption, this word enthalpy you come across in the first year parts of periodic classification, where enthalpy is nothing but heat content of the body. So the change in enthalpy when 1 mole of the substance is absorbed, if you remember, the enthalpy definitions are all with respect to change, where we show it in terms of delta. So that change in enthalpy is what we call it here. So in these cases here, what will happen is this adsorption will be an exothermic process, and in the same way, if the molecules have to go back, that is after they have been attracted, if they have to go back, that process we tend to call it as desorption. D indicates removal of salts, adsorption, desorption. So and since adsorption is an exothermic, this will be the opposite of that, that is endothermic in nature. So this is how the extent of adsorption will be dependent on temperature factor. So temperature will be an important factor in understanding all these parts, where naturally adsorption will increase if you decrease temperature, or adsorption will, it's more so you can say that it is an inversely proportional phenomena, that temperature and adsorption is inversely proportional. So this is about the factor of temperature that we tend to see in this case, and the next one that we have is pressure of the gas. As already conveyed, pressure is having certain relationship with temperature. So the moment you give pressure, what do you mean by that? You are getting the molecules to get closer and closer. So at a constant temperature, now this is maintained because there has to be some standard for it. So this, if you maintain at a constant temperature, it is seen that the extent of adsorption increases with the pressure. For temperature it was inversely proportional, whereas now you are able to see that it is directly proportional. Why it is directly proportional? Because increasing pressure means what? You are trying to get them together. So the surface which is there, if you put pressure on these molecules, naturally these molecules will be coming on the surface, basically to say that both these will be coming as much closer as possible. So this is how pressure plays a role. The effects of pressure differs among various states of matter. Very natural, because in solids you already have molecules tightly packed, liquids a little far away, gases freely. So their pressure role will be different, and that is why to understand the pressure, arrangement of molecules will be very important. What do I mean by arrangement of molecules is nothing but whether they are present in solids, liquids or gases. So these are the four factors that we have seen. Just to go through these four factors that we have here. So the first factor was nature and surface area of the adsorbent. After the surface, you then went to the gas, because that is the one which has been adsorbed on the surface. You then have temperature, inversely proportional, and then pressure, which is directly proportional. Now, having seen certain factors of this adsorption, now let us go through the types of adsorption. And in this types of adsorption, we have mainly the two types. One is physical and the other one is chemical. Now, the word itself will give you some idea about it. Physical adsorption is nothing but their coming together is determined by certain weak physical forces. Physical forces essentially indicate the weak forces that have been present. Whereas chemical adsorption means whenever a surface comes in contact with the molecules, or the other way around, when the molecules come towards the surface, they are being attracted together by chemical bonding or chemical forces of attraction. A small graphical representation is been shown here with respect to physical adsorption and chemical adsorption. You can just see that when you increase temperature, physical adsorption, the extent of adsorption is coming down, and then it is becoming a constant of sorts. Whereas here it's not like that. Actually at low temperature it is low, it is increasing and then decreasing. Why is this so? So for this we may have to again come back to this graph after understanding this concept in a little more deeper way. So at the outset, what is physical adsorption, what is chemical adsorption? It is just that these are generally governed by physical forces, whereas chemical adsorption is mainly forming bonds or chemical forces which have been present in that. So let us see some aspects regarding this physical and chemical adsorption, and then maybe we can again come back to this graph. Just differences table has been put up here where we can study each and every point in these cases. So what are those aspects? Let us just see. As already told you, physical adsorption will depend on weak forces, physical forces which are parted together, whereas chemical will definitely depend on the strong chemical bonds which are being generated. So the moment it is weak force and that is a strong force, it will definitely be highly specific. What do you mean by specific here? If a molecule is getting attracted on the surface, it will be tightly held. The molecule will not be moving here and there. It will be held at a particular place because they are held by tight, strong chemical bonds. Whereas what is the problem with this? It's a weak force. So you can't guarantee that the molecule will stay at one particular place. So it will not be exactly specific in nature. So having seen these two properties, actually the differences are shown here, but what you can do is you can interrelate all these differences in cases. The third one, it is reversible in nature, this is irreversible. Again, reasoning is nothing new. You just got to correlate with these two. It's a weak force, so naturally it is not specific at a particular place. So what will happen? Molecules will come and get attracted on the surface, and because it is weak, it will again go back. Come attract, again go back. So that is why it is reversible, reverse. Whereas that is irreversible. Why it is irreversible? Strong chemical bond. Because it is strong, highly specific, and then since it is highly specific, it will not leave the molecules very easily, and therefore it will be irreversible. Let's look at the fourth point. Enthalpy of adsorption is low. Enthalpy. What is enthalpy? Heat content. Why it is low? Because the forces are weak. Now since the forces are weak, naturally more energy is not required, but here the force is strong. So what do you mean by enthalpy of adsorption? So if adsorption has to happen or desorption has to happen, high energy is required because strong bonding holds them together. So these are the four differences we have seen now correlating with each other. What about the other four differences? Low temperature is favorable. Once again, take it back to the first point there. Why low temperature is favorable? Not strong forces are present there. So you don't need a very high temperature to generate the reaction, but there you definitely need. Because since strong bonds are present, if you put little temperature, nothing will work out for you. So therefore, high temperatures are required, and then activation energy is also high. The study of activation energy, will be doing it more in detail in part 5, but just because I have come across this point here, let me just give you a small idea where suppose a reaction has to happen and it needs 100 joules. Now we use a catalyst. What is the role of a catalyst is, instead of 100 joules, it just sees to it that you may require just 60 joules. So what is the role of a catalyst? It is just trying to reduce the energy that you need for a particular reaction. Now in these cases, you can understand that activation energy as such is not needed because it is general weak force, whereas there definitely it will be needed. Multi-layer formations are seen because they are not specific in nature. Since they are not specific in nature, a molecule gets adsorbed, then again since it's not a strong force, it keeps moving around, so multiple layers keep forming, whereas there it's unilayer because strong force of attraction takes place. More easily liquefiable gases are readily absorbed, whereas here gases react directly with the adsorbent. Here it is more of a weak force, whereas there the gases will actually react with the adsorbent, and then maybe if you want it back, you can supply temperature and remove them. So this is how we come across the differences of these physical adsorption and chemical adsorption. In short, we also have another name for it, which is physiosorption and chemisorption. These are other two words that we use for this. Now having seen this aspect about differences, let's come back to this graph now. So with all that understanding, we now need to understand or try to reason why the graph is so. The coordinates remain the same. It is extent of adsorption and then temperature is at the bottom. What you are understanding here is that adsorption is pretty high in physical adsorption. Some adsorption will be there. If you increase temperature slowly, it is saying that the adsorption keeps on coming down. Now why does it come down is because since it is having a weak force of attraction, if you give temperature, what happens? Temperature, if you increase, which is happening here, will definitely give energy for these molecules. And since the force of attraction is not strong, if you supply energy, all these molecules will run away from this solid and the adsorption process will be reduced. And therefore, you can see that with increase in temperature in these cases, the physical adsorption goes on decreasing. Then what about chemisorption then? It will have some sort of adsorption, but here if you increase temperature, because please remember that the last point which had here, that gases which react with the absorbent are favored. So here there is actually a reaction which is happening here. And for a reaction to happen, it is good that if there is temperature for it, and therefore you can see that in the graph, you are able to see that at the start the extent of adsorption is increasing because high temperature is favored for chemical adsorption. We have already seen in the differences. But too much high also will not be favorable, because when temperature is there, no doubt nicely the molecules will adsorb with the surface which is present. But very high energy will give excess energy for the molecules to rather go away from the system. And that is how these two graphs can be understood in nature. So this is all about this physical adsorption and chemical adsorption. As told, they also have other names called as chemisorption and physisorption. So this is all that we have about the theories of adsorption in these cases. Hope you have understood this well, and keeping this as our basic concepts, we are going to build up with further concepts in this adsorption and then move on to catalysis. Thank you. Sai Ram.